Hello all, I'm Rani Seerapu. I'm here to present my Dialect AI, which is a CLI-based debate simulation engine. It captures structured debates between two AI agents over 8 rounds with memory control, validation, and a final judgment. All modularity built using LangGraph style node abstraction. Coming to the architecture, each of our components in the system is a standalone Python node. The pipeline flows from user input to 8 debate rounds, memory logging, and judgment. Agent views are restricted. They only get their prior arguments and their opponent's last reply. Here we have a quick glance of the user input and CLI interface. The CLI interface begins with a user prompt to enter the debate topic. This triggers the system and runs the full debate between scientist and philosopher for 8 rounds, ending with the final judgment. As shown in the screenshot, we display the full transcript, the judge's summary, and declare winner and the entire reason stating why judge has chosen a particular professional as winner. Sometimes we have a draw too. Yeah. Just a quick note, since the debate logic relies on OpenAI's GPT 3.5 Turbo, you will need to set your API key. You can do this by creating an environment file in the root directory with the OpenAPI key equals to your own API key, or export it as an environment variable before you run this script. So here we have agent nodes and turn control, memory management nodes, judgment node. So what happens is each agent is given a structured system prompt tailored to the debate topic and their stance. Validation logic ensures the current agent speaks at the right time and never repeats a point. Our system is faithful to the LangGraph spec. It is designed in such a way, and agents do not share the full debate state. They only access what's needed to craft a new point, their own statements, and the last opponent's reply, right? So, what happens in the judgment node is after 8 turns, the judge node generates a concise debate summary, gives a rationale and clarify names the winner, and he gives out the name of the winner, all based on the full transcript. Here I have a snapshot of the logs. We can see that all node transitions including agent responses, memory updates, and validations are logged using our custom logger. We have included both UTC and local time for complete traceability. The final verdict, including the summary, rationale, and winner, is also captured. The snapshot from debate log, that is the log file, shows exactly that, providing a full audit trail of the system. So here is our DAG diagram showing the LangGraph style node connectivity. This satisfies the structural visualization requirement. We have created this using Graphviz to statically represent how each node flows from user input through agent turns, validation, memory, and finally to the judge. So, how to run the program? The system actually runs through a clean and interactive CLI. You can start the debate directly with Python main file and observe the full 8 round debate process directly using the Python driver script. Input your debate topic when prompted. The system will alternate turns between the agent A, which is scientist that I have chosen, and agent B is philosopher. Maintain isolated memory for each agent, enforce valid turns, and avoid duplicate logic. Log every transition, memory state, and final outcome. Display a structured verdict from the judge node. This project is modular, readable, and structured for reuse. Node logic, memory handling, and validation are cleanly separated. What I have built is a complete standards aligned debate system featuring contextual memory, strict turn validation, comprehensive logging, and a judgment node, all orchestrated through a land graph style architecture. So that's Dialect AI, a focused, modular, and explainable debate DAG implementation built for clarity, evaluation, and experimentation. Next, we will have a live demo. In addition to the live demo, I have also included a separate document containing four full debate transcripts generated by the system along with the logs. Each example demonstrates a different topic, showing how the agents argue, how the memory evolves, and how the judge delivers a rationale and winner. These examples help verify the system's consistency, logical structure, and versatility across domains. Yeah, so let's start with a live demo of the project Dialect AI, a multi-agent debate system where two agents here have chosen a scientist and a philosopher engage in structured eight-round debate over a user-specified topic, followed by judgment and summarization using OpenAI's API. Yeah, so let's run the main script to start the eight-round debate. So here I have initiated. Now it is asking enter topic for debate. So I give it a topic. So we'll now see alternating rounds between the scientist and philosopher, each generating arguments using OpenAI, right? You can see that. At the end, we should see a summary from the judge. Let us wait. Yeah, it's already up. So here is a summary of the debate, and it is announcing the winner, and it has a rationale for the same. Why judge has chosen philosopher as the winner for this debate, right? So now we'll have two key output files as well. So what is that? We have a log file. Let me pull it up. Yes. So it has a full system logs with I have also input a UTC timestamp as well with a local timestamp. If we have users across the world in different time zones, it will be useful. It's just an add-on. And yeah, so we have all the logs here, turn by turn, what is the everything here. Yeah, so here it is. Now let us check the debate DAG. We wanted a Graphviz flow. It is loading. Yeah, it is up. So it is in alignment with whatever is going on. We have the prompts per user input. It is given. It is validating, host agent one, and so on. And final is the judge here, right? Next, we have some interesting part. Yeah. So what is that interesting part of this project? So we have a requirement stating a memory node stores and updates a structured summary or full transcript of arguments. Each agent only receives relevant memory, no full state sharing, right? So let me quickly pull my memory node. Yeah. So here it is, right? So this is a simplest component, memory node. It logs and passes forward the unchanged state. So the system maintains an auditable trace, right? So what does it do? This node doesn't modify the state. However, it just ensures we have a complete timestamp trail of how the state evolved being nodes between the nodes. And this allows agent to work in a stateless way, right? While the pipeline remains fully observable. Now, let's check our selective memory logic. Let's pull up our main Python file. Yeah. So now let's select the selective memory logic, right? So what's happening here? So here we this part itself we have the selective memory being enforced. Each agent gets only the topic, the debate prompt, my history, all its own previous arguments, that is with respect to the agent. Opponent last, we have only the most recent counterpart from the other side. Importantly, the agent does not get the full history, so there is no leak of global context, just enough to stay logically consistent. Now, let's see where it is actually used for our agent call, right? So, this is where the agent is initialized with a memory function scoped specifically to its name. This ensures that when create agent node is called, it receives a curated view, not global history, making it more realistic, controlled, and in line with cognitive modeling. So, this approach guarantees stateless agent logic, isolated context views, no bleeding of previous rounds outside the agent's memory, full reproducibility through log transcripts. So, together, these two block of codes, right, ensure separation of memory access from agent logic, keeping the system modular and debuggable, right? So, this completes the demo. The system can be extended again with a few customization, the agent memory summarization, and all. Yeah, so this is where I wrap up my live demo. Thank you so much for watching.